Let us see how to solve this question. A shell is fired from a fixed artillery gun with an initial speed u such that it hits target on the ground at a distance r from it. If t1 and t2 are the values of time taken by it to hit the target in two possible ways, then the product of t1 t2 is. So basically, in both the cases we are being told that the value of range is same. And also the initial velocity is same in both the cases, but we are given that the values θ1 and θ2 are different. Now when the range is same and also the initial speed is same, for the range to be equal, these two values must be complementary, which means that the sum of these two angles must be equal to 90 degrees. So the value of θ2 can also be written as 90 minus θ1. Since the range is equal in both the cases with the same initial velocity, the angles must be θ1 and 90 minus θ1. So, in this case, the value of range can be written as u square sine 2 θ1 by g. So, this is the range that we are given in the question, and we are also being asked to calculate the product of t1, t2. So, we know the time of flight t1 can be calculated as 2u sine θ1 by g, and t2 can be calculated as 2u sine 90 minus θ1 by g. So this product t1 t2 is nothing but 2u into 2u, which is 4u square into sine θ1. Sin 90 minus theta is cos θ1 by g. So this is, let us take 1 2 here, and we have 2u square into 2 sin θ1 cos θ1 is sin 2 θ1 by g. Now we know the value of u square sin 2 θ1 by g is, this becomes g square because in the denominator we have 1g and 1g, this is g square. So this can be written as 2 by g into u square sin 2 θ1 by g. And we know this value to be equal to capital R. So we can directly substitute this to be range R. So this value is nothing but 2R by g. So the value of the product T1 into T2 is nothing but 2R by g. And the correct answer to the question is option C.